welcome to the stream of SLS going all the way to the moon. Uh, we're glad to have you here today, and basically, we're going to watch NASA launch what is now the biggest rocket in the world, and this is going all the way to the moon, as I was saying before. It's really exciting because it's the first time that NASA is starting to develop technology to actually bring humans back to the moon. So, of course, there's lots of anticipation for this rocket launch. It's been a long time waiting because this rocket has basically been ready to go for a couple of years now. They keep saying, oh, it's just a little bit around the corner, a little bit around the corner, just a couple months more to go. And that's been basically kicked down the way here. But finally, we're here. The rocket's going to launch in about 15 minutes. So this could be the day that we finally get to see this thing fly. So we're really looking forward to this. Today we're just going to go over a lot of the stuff that's going to be happening with the rocket launch and the way the vehicle is operating, and also what the mission plan is. And at the end, we'll, of course, hopefully get to see the rocket launch fly. So we'll be switching to the NASA live stream to see that. So it should be quite exciting. We're glad to have you here, and hopefully we can have a good time. It's a bit early in the morning for me because I'm all the way in Germany right now. Just to give you a bit of context, I am part of a student group that does rocketry here at the University of Bremen. And we are trying to build a rocket which will go to space. So not quite as ambitious as the Artemis program, but we're well familiar with the idea of things getting pushed back as you realize things are maybe a bit harder than you may have anticipated at the start. So we can sympathize there a little bit. If you are in the Bremen area, we are actually currently exhibiting at the Space Tech Expo. So if you're in Bremen and you want to see some cool rocketry stuff, definitely stop by. There's all kinds of cool rocket companies that are there displaying all their stuff. Also, some student groups. If you go to the right section in Hall 6, there are some student groups there that are displaying all of their rocketry stuff along with us. So if you're there, please definitely consider stopping by. But let's get back to the task at hand here. We're going to be launching a moon rocket. So what's going on with that? So right now, of course, if you are familiar with the SLS system, it's basically looking like the rocket that's here on the left. And basically it's about 100 meters tall, just under 100 meters tall. And it has a diameter of almost 10 meters. So it's really kind of a monster of a vehicle. And it's definitely the biggest rocket in terms of mass that has taken off from the Earth since the space shuttle days. So kind of a cool callback to that. And a lot of the stuff that's on this rocket is actually old stuff that used to fly on the space shuttle missions. So we're going to see a lot of a return of those types of things on this rocket. So you may notice that the solid boosters that are strapped to the side are looking a lot like the space shuttle solid boosters, and that's exactly what they are. They're just a little bit modified in order to handle the things that we want for SLS, a little bit upgraded. And the engines that are actually on the bottom of the main stage there are also the space shuttle engines that used to fly on the space shuttle. So a lot of parts are getting reused here in order to perform the tasks that we want SLS to be able to achieve. Yeah. Basically, if you remove the orbiter of the space shuttle system and kind of extended the main fuel tank and then attached another stage to the top of it, boom, you have an SLS. The main thing here, though, is going to be getting some pretty crazy payloads into orbit. So, of course, here you see 95 tons to low Earth orbit, and then finally the 27 tons to a translunar injection. So this is definitely the biggest rocket, if it works, that is online right now in the world. So we're really looking forward to see it, of course. So as I was saying about the core main stage, it's kind of similar to the main external fuel tank to the space shuttle. It even looks the same color. It has the same insulation foam that they put on the outside. So that's why it has that orange color. And it's going to be powered by liquid hydrogen and oxygen, just like the space shuttle main engines were. And a lot of the materials that they use for it are also the same. Still just using aluminum for the tank inner surface. And of course it's powered by those space shuttle main engines like I was talking about before. And basically they're using that system to power the rocket basically all the way to space, because those boosters on the side get you the boost so that this thing can get off the ground, because it actually doesn't have enough thrust to lift its own mass. with just those space shuttle main engines. So it's just like the space shuttle where you need those boosters to kind of get you off the ground. But then basically this first stage can basically take you all the way essentially into orbit, just before you get into orbit. So it's really a powerful first stage, one of the most powerful first stages I would say in the world. And that second stage is basically what gets you from almost orbit all the way onto the trajectory to get to the moon. So as I was saying about the boosters, they're basically derived from the space shuttle boosters that they were using back in the space shuttle days. The only difference is that they've actually added, so the space shuttle boosters used to have 4 segments, and this one actually has a 5th segment. So if you like count the segments in the picture there, you'll notice that there's an extra segment. That's pretty much the only difference. They're still using the same propellant combination, which is the polybutadiene acrylonitrile. So it's a similar propellant combination as they had in the space shuttle days there. They're also using the same steel material to form the combustion chamber, which is actually a bit interesting because usually you don't see steel too often as combustion chambers in the modern times. Usually they're using things like carbon fiber. But if it works, I guess don't change it. But I don't know. Maybe they'll have an upgrade in the future with carbon fiber. I think that's also in the works. So that should give them a bit more performance for the system moving into the times when they're actually going to be putting humans onto the rocket. Finally, you have the cryogenic upper stage, which just like the first stage is also using liquid nitrogen and oxygen. Sorry, not liquid nitrogen, liquid hydrogen. Still early in the morning for me. And the rocket that they're using to power that stage is actually the RL-10, which is the same rocket that they use on the Delta IV. It's actually a really fantastic engine because it has the highest specific impulse out of all engines in the world, I believe. It's actually a pretty crazy engine. So it uses the expander cycle, and it's able to exploit that expander cycle in order to get like a really high ISP, which is obviously what you want if you want to have the optimum efficiency so that you can get the most mass you can all the way to the moon. And it can kind of do this because you don't really need a super powerful engine at this point because, like I said, you're almost in orbit. So you can kind of have this low thrust but high efficiency engine for the last phases of the rocket launch. So yeah, this will be like the third stage of the Apollo. So it's kind of operating in that similar neighborhood. And then finally we have this Orion capsule, which is where of course the astronauts will live. And so once you're on the trajectory to the moon, basically the second stage will separate, and then this will be what flies all the way to the moon. It has power, and it has the possibility to actually maneuver itself with some hypergolic propellants. There's not going to be like much that they have to do in terms of orbital corrections on the way they're going this time, but they're going to test the system to make sure that it's all working properly, and that they will actually be able to do orbital maneuvers when they get to the moon, when they send astronauts there, of course, because they have to go into this crazy halo rectilinear orbit that they're going into around the moon, and of course that requires a deceleration burn and things like that. So this will also be getting tested. Let's switch back to the live stream here and see where they are on the countdown.
It was a great celebration. The nation was almost euphoric.
That's one small step for man, one giant leap for
So you can
mankind.
see here that we're just
There are
in
so
a
many
hold at
things
T-minus
that
10
we
minutes.
could eventually learn about
So
our universe
we'll be checking back in to
and
see
spacecraft
like where they
that we
are in
deploy.
terms of the progress towards the launch. I think this is
We are a nation of explorers.
I believe this is like a scheduled hold. So they go through this process where they actually hold the vehicle at certain points in order to do like checks and stuff. This is like kind of a callback to like the old days of how they did rocket launches, where they would have like these scheduled periods where they would be doing these different types of checks to make sure the vehicle is all okay. So don't freak out if like the clock stops in various periods and you see that things aren't moving. It's kind of a bit more like I would say it's more like a Delta IV launch or something like that, because they have the similar procedures as what a Delta IV would be using. And so it's not like SpaceX where when the clock stops, okay, we're recycling to tomorrow. So yeah, we'll be checking in back with the clock and the live stream. But let's continue to talk about basically the staging sequence that we expect for the SLS to go through. So, of course, the first stage of the mission is actually going to be the launch itself. So the rockets will fire up. That's going to be both the boosters that are on the side and those 4 main engines on the core stage, and that's going to basically fire for about, I think the boosters go for about 90 seconds. And once those boosters are all depleted and finished up, we're going to see the separation of those boosters from the main stage, but that main stage will continue burning all the way into what is near the orbit. So that's going to take probably around like 8 or 9 minutes. It's kind of a slow burn because, of course, these engines that are on the bottom are also really efficient. So they optimize the amount of fuel that they use so that they don't use so much, but they still get a lot of performance. So that was kind of the whole compromise that the space shuttle engines were delivering to really make the space shuttle an effective launch vehicle. So good that they're still using these engines. They're really cool. So once the burn has started, though, they at the very end of the launch sequence, going towards moving into orbit almost, you can actually get rid of that escape tower that they have on top of the Orion capsule. The reason why they need that escape capsule is because if there's anything wrong with the rocket, they can basically use there's like a solid booster that's on the tower that activates, and it'll pull the Orion capsule away from the vehicle if it's like exploding or something. And it's really, really powerful. It has like the power to generate like 15 Gs of acceleration to pull this capsule away from an exploding rocket. So you can really get out of there really fast. And this basically is what's going to keep the crew, if there were a crew. There's no crew today, so don't worry about that. It would keep the crew safe from something that would be disastrous on the vehicle. But once you're almost all the way into orbit, you don't really need that anymore because, well, number one, there's like way less fuel in the main stage of the rocket. So if it did explode, it's like not as bad. But you can actually, instead of using the abort thrusters to get you away from the rocket, like you can just abort to orbit. So essentially, if there's a problem, you can kind of just separate from the main stage and kind of come back under Earth's gravity, and that's fine, you know. So once you get to that point where you're safe from, you know, getting away from the vehicle, and you can still just separate from the rocket and just land and not have too much of a problem, they can get rid of that launch escape system. I'm not sure if you'll be able to see this in the live stream of the rocket launch. I'm not sure if they have like cameras on it, but I think it'd be pretty cool if they show it. I don't know. We'll see if we get to see it properly. Then once the main stage gets nearly to orbit, they'll have the main engines basically cut off, and that'll give the opportunity for the second stage to separate from the main stage. And then you'll see the upper stage basically ignite and pull away from the vehicle, and it'll continue all the way into orbit, and then finally on its trans-lunar injection, which will basically be this crazy elliptical orbit that's going to take it all the way out to the moon. Because remember, like when you first go into low Earth orbit, you're just going in a circle. So in order to get to the moon, you have to modify that orbit by injecting extra energy at your periapsis, which is when you're closest to the Earth, and that will basically push out your apoapsis, which is the end of the orbit. So it pushes it away if you inject energy, and that pushes you into that big long elliptical orbit that can take you all the way to the moon. And that needs roughly around 3,000 or so meters per second of extra velocity. Yeah, if that doesn't mean anything to you, it's basically what's 3,000 meters per second in units that make sense? Like 10,000 kilometers per hour extra. So you need about 28,000 kilometers per hour just to get into orbit, and then need 10 more thousand to get to the moon, essentially. Yeah, I think that's a good comparison. So it's like 1/3 extra the energy. So once you're on that translunar injection, then basically the engines will turn off, and the rocket will just kind of coast all the way until it is reaching at the apoapsis of the orbit, and then the rocket is basically at the moon, and then it can make a maneuver and do some stuff. But once this translunar ejection is final, like the orbit is made, basically that Orion capsule will separate from the second stage, and it'll operate as an independent vehicle as it coasts all the way to the moon. And then once it finally reaches the end of that orbit, then it's basically arrived to the moon. It'll have some orbital maneuvers that it'll do at this point, but yeah, that'll happen in some days. So it won't be obviously happening on the stream. But definitely check up with NASA on their social media and on their Twitter, or I don't even know what NASA's using to update these days. I think they have a Twitter. Yeah, check up with them and see how the progress of the mission is going. They may even do like small live streams of certain events that are happening around the moon. I'm sure they're excited to show this off. So yeah, they'll be testing their whole system there. Let's check back with the live stream. Okay, it looks like they're still in a hold. Let's see what's going on.
And then an ignition source, that's what gives you your reaction, your thrust, your basically controlled explosion that then comes out of those rocket engines. So fully tanked, these are cryogenic fuels, hundreds of degrees below zero, so we've got a spray-on insulation across the entire vehicle. As it's sitting out there in the Florida air, it's a little bit warm tonight, but we need to keep those hundreds of degrees below zero. It takes a lot of energy to do that, so the less you have to use to keep them cold, the better, which is why we have that insulation. So we're gonna be seeing SLS take flight for the first time tonight as we clear all of those final issues. Again, this is going to be one heck of a show when this thing launches into the night sky. So with that, send it back over to you, Megan.
So it looks like we're still at the hold at 10 minutes. So yeah, nothing to worry about right now so far. The launch time that's officially registered is in 28 minutes. So as long as they don't fall behind that clock, I think everything is fine. Yeah, pretty cool animation they made of the rocket though, and they can kind of spin it around and show you stuff.
Does open at 1:04 a.m. Eastern Time. Now, today is a big deal. Apollo 17 in 1972 was the last time humans stepped foot on the moon. That the rocket you see right there behind us, illuminated in the darkness there, is the first step back towards getting us to the moon. Now, Artemis 1 is the first integrated flight test of NASA's deep space exploration systems. That's the ground systems here at Kennedy Space Center, the Space Launch System, or SLS rocket, and the Orion spacecraft. We will send an uncrewed Orion spacecraft farther beyond the moon than any of the Apollo missions before it. For Artemis 2, Orion will have astronauts on board.
They like to keep mentioning that it's further beyond the moon than
Then future Artemis
Apollo.
missions will land the first woman and first person of color on the surface of the moon. So Kayla, why do we want to go back to the moon?
The moon's a super interesting place to study. It can tell us a lot about the Earth, its own formation, but also more about our solar system. And we also want to return this time in an international partnership for a permanent presence on the lunar surface that'll teach us everything we need to know to travel onto Mars.
Mm-hmm. And what about for you? I mean, you have the possibility of maybe being selected for those future missions because the Artemis program can choose from any of you guys, any of the NASA astronauts.
It's a crazy time to be a NASA astronaut and even imagine that that could be real. I think we're all just honored to be a part of the team that's doing this. We're just a small representation of all of the amazing human beings around the world that it takes to do something as audacious as returning to the moon, learning what we need to go onto Mars. So we're just all excited to support the program in any way we can. But of course, a ride to the moon would be incredible. So
yeah.
I think we're all just dreaming about those moonwalks.
Now, since Artemis 1 is setting the stage for those future crewed missions.
So just another interesting thing about the SLS rocket, like they started tanking this rocket like 5 or 6 hours ago. So because of how much hydrogen they actually have to put into that main core center stage there, like fueling takes forever. like if you compare that to like the Falcon 9 or something, like they can start tanking that like, you know, 30 minutes before the rocket launch, because the fuel they're using is like a lot denser. So liquid oxygen, and it has a density of about 1,100 kilograms per meter cubed, and RP1 has a density I think around 900 kilograms or 800 kilograms per meter cubed. So the fuels they're using are way more compact, and so they can fill that tank a lot faster. But for the SLS rocket, because of how undense hydrogen is, it's only about 70 kilograms per meter cubed. So it's like a 15th of the density of the propellants that Falcon 9 would be using. And so because of that, the fueling takes like way longer. So like they have to start preparing this basically half a day in advance of the actual launch. So it is kind of a long sequence compared to other types of launchers. But yeah, let me just quickly go over to the trajectory that the rocket is planning to go on. So once it gets into the translunar injection, basically the Artemis program has a bunch of like target places that it's going to be going through on its way to the moon. And you can kind of see them here. They kind of want to test this whole halo rectilinear orbit. They won't be actually going into it on this mission, so they'll be just kind of doing these loops around the moon, where they go into these elliptical loops where they kind of come out to touch that orbit, but they don't stay in it, you know, if that makes any sense. So they'll be doing basically deep space testing on the Orion capsule and how it operates and whether it's actually going to be able to keep the humans alive during the mission. That's kind of the whole point of the test. But they'll also be testing the propulsion system on there. They'll be testing the power system because they're using solar panels to power the whole capsule. Yeah, they're basically, it's like a modern Apollo capsule almost, if you can imagine it that way. So that, yeah, that's kind of the plan of how they plan to actually, what they plan to actually fly when they get there. And of course, it'll come back in, I think it's around 3 weeks or so, and it'll do a splashdown landing in the ocean, which will be the first time that they land a capsule like this at the velocities from the moon. So it should be pretty toasty and exciting. They'll probably live stream that as well, I'm sure, NASA. So stay tuned for that kind of stuff.
How we go to Mars and out into the solar system and maybe beyond.
It is incredibly exciting to be part of this Artemis team. It still feels pretty surreal to think that I might one day walk on the moon.
To see a woman and a person of color on the surface of the moon, to be able to say that space is for everyone and that we go to space to make life better here on Earth for everyone. I know that tears will be in my eyes.
My message to women and girls out there is to find your passion, whatever that is.
Don't let anyone tell you what you can do or can't do. Only you can realize your dreams.
Space is for everyone. And if me being in this role helps to send that message, I think that's a great thing.
And I just actually love that I don't feel like a...
So you can see there on this top view that the fueling is still happening, because you see the condensation clouds that are coming off the vehicle. And of course, because they're loading cryogenic hydrogen and cryogenic oxygen as well, the temperatures they have to get to are like really cold. Like for hydrogen, it's going down to like minus 250 degrees Celsius, which is, you know, colder than anything you can imagine probably. So when the fuel comes into contact with the hotter environment of the Florida atmosphere, it creates basically these condensation clouds. So they're not clouds of like smoke or anything. It's actually just water vapor that's condensing because of the cold environment around the fueling process.
Everyone, you know, space is for everyone. You heard that a few times in the video.
And just to also point something out, whenever you're fueling a vehicle, you have to kind of release some of the product that you're fueling when you're doing it cryogenically. And this is just because there's as the tank warms up, basically the cryogenic stuff inside of the tank will want to boil off. So it wants to create more gas, and that starts to pressurize your tank. And if you don't let any of the gas out, then basically you'll have an overpressurization and the tank will explode. So you have to always be letting out some gas, and that's why you get those streams of condensation clouds that are coming off the vehicle. This is totally normal, which is why they keep fueling the rocket right until they're about to launch, and so they can keep topping off the tank because they have this boil off situation.
Inspires me. So many of those women are my friends, but also they're just such fantastic engineers and scientists and just so many roles at the agency. I've always thought one of the strongest teams that you could ever find is a family, and families have men and women, and so our teams are stronger, I think, when we have that balance and that diversity. So that was exciting. But for me, I was a part of the Apollo generation, and I was very inspired by, you know, Neil Armstrong and Buzz Aldrin and Mike Collins on Apollo 11 and all the Apollo astronauts. I just cannot even imagine the inspiration, though, for a little girl. I mean, it never occurred to me that I wanted to be an astronaut, but of course there were no women astronauts then. I think what's going to happen now with the Artemis generation is that first woman and the first person of color is just going to have a huge impact on the next generation.
Right. We are just watching with bated breath, and I know that it's going to mean so much to little kids to look up to them. And we understand, too, this is a huge, I mean, when we launch Artemis, it's going to be a global accomplishment. We have the Artemis Accords, which are helping us make sure we explore peacefully. Can you tell us more about those?
Yeah, it's really important, actually, especially because you know, unlike in Apollo, where it was actually just a few countries that had the capability to go to space, now those capabilities are proliferating throughout the world. And so what we do with the rocket is really important, and how we go is just as important. And how we go is as teams and with our partners, and with a sense of the responsibility that we have as we go out into the solar system to do it peacefully for scientific purposes and responsibly.
Right. Pam, you have a great sense of teamwork, and this is definitely not our first time. You know, there's a lot of things that go into testing out a first-time vehicle. There's actually dynamic activity going on right now. So how does this first flight test of SLS compare to other first times, you know, with Shuttle or with Saturn V before that?
Well, I can do even better as a test pilot, right? So there's a history there. In fact, the amazing thing about this is so first flight of a first aircraft, you actually taxi it out to the end of the runway and then run down the runway and come back and check all the data. And then you might take off once and go around the pattern and come back and land. This is a little bit like taking off and going to fly a full mission on your very first flight of an aircraft. And so everything has to be right. So this compares very, it's very similar to the experiences that all new rocket developments have, where, it's not just about learning the hardware, that's a big piece of it, but it's also about gelling that team together and your procedures and how you're going to deal with issues that come up, because they will come up. They always come up.
Exactly. And you have that experience as a test pilot, but also as a former astronaut. In that video, we saw you getting your induction into the Astronaut Hall of Fame, which is pretty cool. So what is your perspective, or what advice do you have for the Artemis astronauts, those ones that are going to maybe set foot on the moon?
If you remember back to a couple of months ago, we did get to this point nearly in the launch process, and that was because they were just having some issues with the valve for filling the hydrogen tank. So these issues are always going to come up, like she was saying, with developing a new rocket, and solving those problems with the operations and the process that you use to actually launch a rocket and figure out how your rocket works is actually this is all kind of part of the process. So things are bound to have snags, and you're bound to see things that you don't expect. So that's probably going to happen lots in this mission. Things may not go exactly according to how they expect, but that's kind of how we have to kind of think about this mission, because again, it's the first flight of this vehicle. It's completely a test. That's why there's no people on board. So to put it in perspective, they actually, when they did the space shuttle, they also had a test flight like this, but they basically had the space shuttle do exactly what they were expecting it to do for the operational mode, and they even put people onto it. So they were like way more, I don't know, cavalier and cowboyish back then, I guess. Yeah, I don't think you would be allowed to put people onto a brand new rocket in today's age, which is maybe a little bit sad, but probably better for the safety of everyone involved.
During today's launch attempt, so why don't we go back over there with Leah to tell us what's going on over there.
Thanks, Megan. And you're right, teams here in Mission Control Houston continue to monitor today's events. Again, they will really kick into action once we have liftoff, and they'll remain on console all the way through splashdown. But quickly, I have to show you something, a little show and tell. It makes me feel like the coolest kid. In school, I've got a moon rock here. I hope you can get a good shot of it. It is from Apollo 15, 1971. And when it was brought back to Earth, it was part of a larger rock. In total, it was 21 pounds. This is, of course, a smaller section of that, but we're looking forward to the Artemis program and being able to go back to the moon so that we can continue to gather these kinds of samples, but this time at the lunar South Pole. We've never been there, and we've never brought samples back from that area, so we're really excited to see what might differ in those samples and the ones that we have here. Now, of course, we've got a whole laboratory of scientists that are able to study all of those samples. We just opened some up for the first time earlier this year, so that we're able to test with new technology everything that we can learn about these samples that we brought back now 50 years ago. So hopefully within the next few years, we're bringing some new ones back to use that same experimental process on and tell us a little bit more about the moon. But just had to show this off. Apollo 15 moon rock. We're looking forward to having some Artemis ones here at Johnson Space Center. And with that, I will send it back to you at KSC.
You were a cool kid before you even had them.
So the reason why they're actually going to, like, one of the main reasons why they're going to the moon right now is because there's actually a high possibility that there's water at the South Pole or the North Pole of the moon, where the sun is not really shining very brightly in certain places. It's kind of like the same way like the South Pole and North Pole on Earth are super cold and always have ice over them. That's because they receive less sunlight from the sun on an annual basis. So the same thing happens on the moon, but there's a potential possibility based on the data that we've collected so far that the reason for that is that essentially there could be like entrapped like frozen water in the soil of the moon in those locations. So if we can actually get some samples and realize that that's the case, it kind of opens up a whole world of possibilities for what you can do from an engineering perspective. Because now, with water already there on the moon, you can actually use the resources on the moon in order to do things like keep a base alive, because of course you need water in order to have humans surviving, right? You have to drink the water, you have to use it to hydrate your food, you have to use it to, you know, generally live. Like, I don't know, take a moon shower or something. You also need water for like a lot of chemical processes and things like this, and for building and stuff. It's like really an essential part of life in the world on Earth. So if you can find water, it really opens up a lot of possibilities there. It also opens up possibilities in terms of rocket design, because now you don't actually have to have all of the rocket fuel that you're going to the moon with on your rocket, right? You can actually use the rocket fuel, or you can use the water on the moon in order to make rocket fuel. Like I was saying, when we were looking at what the SLS will actually run on, it runs on hydrogen and oxygen. And how do you make hydrogen and oxygen? Well, you take water and you break it apart into its components, which are hydrogen and oxygen. So you can literally make all the rocket fuel for SLS with just water. Now, SLS won't be actually landing on the moon, but potentially in the future, when they're looking at future landing vehicles for when they actually want to start building bases on the moon, they'll probably be looking at potential, if they find the water, they'll be looking at potential opportunities to use vehicles that can take advantage of the water that's on the moon in order to basically make their operations more efficient and make it so you don't have to basically take all your fuel with you to the moon. And once you've kind of established that, you can really start using the moon as a potential place where you can, get to other places in the solar system, of course. If you don't find water, it doesn't really make sense to go to the moon in order to get to the rest of the solar system, because the moon's kind of not necessarily directly on the way to the rest of the solar system. But if there's water there, that kind of changes the game, because then you can refuel there. So it can actually be more efficient to stop there than to launch things into low Earth orbit and go from Earth. So that's the other cool thing about if there's water on the moon. So definitely something that we'll be looking into as they progress and as they start doing some science in those locations. It would be really awesome if they actually bring back a sample and there's water in it. That would be probably revolutionary, I would say, from an engineering perspective anyway.
European Space Agency, and together the company and ESA, they provided the European Service Module.
This is where we are, by the way. We're in Bremen.
An important part of the Orion spacecraft. So we
and this
have
is because this
quite
is
a bit
where
of
they
people
build
there.
the Orion module.
A more reasonable time over there in Germany. It is 7 a.m. So I'm going to say Guten Morgen to them. Did I say it right? Guten Morgen to them over there in Bremen, Germany. Again, the Airbus company. All right, so let's get another check on the launch team with our Daryl Nail, who's inside there and has an update for us.
Yeah, that's right, Megan. So we are clearly in a delay now. The NASA test director, who's basically flying the ship for the launch countdown tonight, has said that we are extending the hold that we were currently in at T-minus 10 minutes and counting. And so that puts us off the 1:04 a.m. Eastern Time launch. We're now slipping indefinitely into the hold. NASA Test Director Carlos Monge saying that we are currently estimating how much work needs to be done before resuming the polling that is supposed to take place 15 minutes before launch. It then goes to terminal count at T-minus 10 minutes. Now we've got an update on the tanking of the upper stage liquid hydrogen tank. Currently 95% filled. We're in topping on that tank. It is the last of 4 tanks in the Space Launch System that needed to be completely fueled up before we launch. Of course, cryogenic tanking, a complex operation that has seen some delays tonight. We had a roughly hour delay after a replenish valve on the core stage liquid hydrogen side required hands-on work by a Red Crew team that went out to the launch pad and tightened down some bolts on the valve and got it fixed before leaving the launch pad, and then launch team verifying that that work was complete. Now currently we're awaiting some work with the range. The 45th Space Wing, which oversees the range here, and makes sure that the airspace and the ocean out over the flight path is clear, and also has the responsibility to destruct the rocket should it go off track. They have been working on some issues with their equipment and sending a flight termination signal to the rocket. There is testing that must happen with the flight termination system that was delayed by a bad Ethernet switch. Switch has been changed out, and now the range is looking to start testing their connectivity to the rocket in order to preserve that safety function that they are responsible for. So again, we are slipping now indefinitely into the launch window. We're awaiting the launch team to evaluate just how much time is required to complete the work to get this rocket ready to launch. And of course, when we have a new T0 for you, we'll report that out right away. Megan, back to you.
Daryl, thank you so much.
So it looks like they're still having a bit of trouble with their valve and their filling process, but that has been at least resolved for now. I expect that it could be that they end up delaying past their launch window, but yeah, we'll see. Hopefully it gets off today. It would be really nice to see it finally in operation. So, but of course, they will wait for when they are comfortable to launch it. Like I said, it's a new rocket, so there's a lot of stuff they have to figure out as they're working with it. And they would like to see it actually succeed instead of blowing up. So we will wait for that for sure.
Generation of spacesuits and geology sampling tools.
There's these facilities that help us train like we are on the lunar surface. These 1.6G offload systems or putting people in the aquatic environment are great ways to train the mobility part, right? Like, what can you do and how different does it feel to be in 1.6G and do these tasks?
We've been training astronauts in geology and geoscience for decades now. The Apollo astronauts had literally hundreds of hours of training in geology before they flew to the moon. It's often said that the Apollo astronauts had the equivalent of a master's degree in geology by the time they flew to the moon. In the intervening decades since Apollo, we've been training astronauts who fly to the International Space Station because when they're on the ISS, they spend time observing the Earth, looking out the window, taking pictures of what they see on the Earth's surface. Now that we're looking at putting astronauts on the surface of the moon, we also take them into the field. We take them to field sites here on Earth that resemble field sites that we expect them to see on the moon.
That's the reason why we take them out into places that are unique, like volcanic landscapes or places that are analogous to the lunar surface, to train them on the scale and fidelity of science that you just can't recreate in these facilities.
And so by combining this classroom and field training, we're able to prep them for fundamentals of geology, the major driving lunar science questions that we have that we hope to address with the Artemis program, and teaching them how to do field work in relevant analog environments.
For just science aspects of developing new spacesuits, can it get you to where you need to go? And then once you get there, can you do the cool science that you need to do? And so that's, can you move effectively and efficiently in the suit to be able to collect the samples or use the tools or the instruments? For the visibility, it's like, can you make the necessary observations that you need to? Or does the suit have the lights on it that it needs to illuminate the surface and make the observations you need to? The lunar South Pole holds tremendous resources that are going to allow us to continue to explore. This is a place that we've never been before. There's so much to be learned from getting boots on the ground and exploring a unique place that challenges us as humans and also helps us develop technologies that make our everyday life that much better.
We think there might be volatiles present at the South Pole. By using these volatiles, we'll be able to do things like create drinking water, create rocket fuel to launch astronauts back to Earth. And so by harnessing the power of the land, we'll be able to help astronauts establish that long-term sustainable presence.
It's human nature to explore. Pushing our boundaries and exploring our universe is, I think, just one of those things that's just stuck in our human nature, and that we need to do it in order to understand the world around us, including our Earth and our solar system.
We just heard there how curiosity is just a part of us. So, with that in mind, why don't we do some social questions? Because some people are very curious to hear what you have to say about their questions. So why don't we pull up the first question here?
So maybe let's, in the meantime, while we wait for the countdown here, let's maybe run down again through the topics of how the vehicle is operating and what's going on with the vehicle. For those who are joining a bit later, and maybe we can just refresh our minds as to how this all works. So, of course, SLS is going to be the biggest rocket that has ever been developed. Well, not ever. I think Apollo was slightly larger. It's the biggest rocket that is currently in operation, if it actually is able to operate today. It will basically have a capacity that is more than all the other rockets to get payload into low Earth orbit, which is 95 tons. And of course, they can get major payloads on that translunar injection going all the way to the moon of 27 tons. There's no rocket in the world right now that can do that. Not even the Falcon Heavy, which is currently, as of right now, the largest rocket. But soon, SLS will be superseding it. It also has a very high takeoff mass of 2,600 tons, which is, again, never before seen since the retirement of the space shuttle. So it's on the same order of that. And basically, in order to make this SLS system, they're reusing a lot of the stuff from the space shuttle days, or deriving it, at least, I would say. you can't. It's hard to just reuse something because the system's obviously different. So they have to kind of change things along the way. But you'll notice that the system kind of looks a lot similar. Like that orange tank looks a lot like the external fuel tank that the space shuttle used. The boosters look a lot like the main boosters that the space shuttle used. They basically just stretched these things, put some rockets in different places, and then that's what's making the SLS. So to go a little more in depth into that, the core stage, like I said, it was a lot like the external fuel tank. It kind of uses the same technology, the same type of aluminum tank material on the inside. It still has the orange insulation foam. The reason why they need that foam is because they're containing cryogenic liquid hydrogen and liquid oxygen. So the hydrogen goes down all the way to like minus 250 degrees Celsius. And so that requires there to be a lot of insulation in order to maintain those temperatures inside of the tank. Because of course it's not minus 250 degrees Celsius in Florida. So regardless of all that insulation that's around the tank, there's still some heat that kind of creeps in. And so you have to always be kind of boiling off some hydrogen as you fuel the rocket. So it's always going to be topping off the tanks as we wait for the launch. And of course, that's necessary when you're in a hold type situation like we are right now. The engines that are powering this core stage are the same space shuttle engines, the RS-25 engines. They're literally the same engines that were powering the space shuttle, like, because they would reuse the space shuttles, so the engines would always get reused. So they've basically just taken all the engines that were being used for the space shuttles, and they're going to be using them on this SLS rocket, which is actually a bit unfortunate because they're not reusing this core stage. So this will be the final march for those engines that would deliver space shuttles into orbit on a regular basis. This will be the last mission that they fly as they do their death dive into the Atlantic Ocean. So in a way, it's kind of a little bit sad if you are a fan of reusability. But yeah, that's the one thing about SLS that's not ideal, I guess, is that, you know, it kind of feels like a step backwards because at least Space Shuttle was partly reusable, right? You would reuse the booster and you'd reuse the boosters because they would land in the Atlantic Ocean and they recover them. And you would actually reuse the Space Shuttle orbiter because it would come back and land on the runway like a plane. The only thing that wasn't reused was that external fuel tank. So a lot of the parts of the rocket were actually recoverable, which was, you know, a step forward in terms of rocket development. So in some ways, it kind of feels like we're stepping backwards here, but hopefully that's just a temporary thing and we move more towards reusability in the future. The boosters, of course, that are powering this are also similar to the main space shuttle boosters. They're just a little bit longer. So instead of having 4 segments, they're going to have 5 segments. And this is basically going to give it a little bit extra thrust, a little bit extra impulse, so that it can launch the heavier mass of the SLS in the end. It's running on basically the same type of propellant, the same type of technology. It's just having that little difference in terms of how long it is. Yeah, in the future, they're probably going to try to switch to carbon fiber for the tank material. Right now, it's still just the low alloy steel they're using back in the space shuttle days. Of course, steel is not the state of the art anymore in terms of booster design. Lots of boosters these days are using carbon fiber to save on mass and yeah, get that little bit of extra performance. Then we have the upper stage of the vehicle, which is also running on hydrogen and oxygen. So that's why they were talking in the live stream about 4 tanks. Those 4 tanks are the 2 that are on the core stage, and then the 2 that are on this upper stage. So in the end, they have 4 tanks to fuel with cryogenic materials. And of course, with 4 tanks, you have lots of opportunity for little issues to come up with, like valves and, you know, temperatures and freezing and things like this. So it's really definitely a complicated system that you have to navigate in order to get this whole thing working. And the thing that's powering all these, the second stage, is essentially this RL-10 engine, which is one of the most efficient engines in the world right now. It uses the expander cycle, which is a very good cycle for efficiency. It's not necessarily the greatest for power, like getting a lot of push, but that's fine when you're almost all the way to orbit, like SLS will be. You can kind of take your time and really get the most efficiency out of the physics, if you know what I mean. So this thing will burn for a long time, like 800 seconds, and it'll basically be moving the rocket from nearly orbital to onto that translunar injection. And then finally, we have the Orion spacecraft, which is the one that's built by Airbus and the European partners of this program. And of course, a lot of the staff for that are in Bremen, which is where we are here in Bremen. So this is our little connection to the rocket. I'm not with Airbus, I'm with a student group called Astra that works in the University of Bremen, but a lot of us are closely associated with the Ariane group. Sorry about this. My alarm's going off. This is when I guess I would usually be waking up. But of course, I got a little early up for this rocket. A lot like a lot of the people that are at Airbus right now. There's a whole viewing center there, and lots of people in Germany got up early to see this because we're really excited to see it go. The special thing about this Orion spacecraft is that essentially it's running on hydrazine. So this means that you don't need an actual igniter to make the propellants, go. As soon as they mix together, they just create flame. So it's a little bit of a simpler strategy, and it's more reliable in terms of making sure that it will work. The only drawback is that they're a bit toxic. So if something goes wrong, you can't really have humans around because, it's it's kind of nasty stuff. So extra safety precautions are required. But yeah, that's kind of the overview of the vehicle. That's what we're going to be seeing flying, hopefully very soon. And here we're talking a bit about the mission.
Let's look at what's ahead for this historic first flight. As we just said, launch is step number one. Those 4 RS-25 engines throttle up, followed shortly after by the 2 solid rocket boosters igniting, sending SLS and Orion skyward. Now on our way uphill, we'll have a number of jettison events. You'll be able to see things coming off of the SLS rocket. One of the most visual ones will be these 2 solid rocket boosters. Now they'll expend their propellant a little over 2 minutes into the flight. They will separate. We'll see them flare off onto either side, and then the core stage continues to fire. We're also going to see the launch abort system come off the top. Once you get high enough in the atmosphere, it's no longer required. You could actually do aborts using engines on Orion and its service module. I will also note that on the launch abort system, it's got those 3 solid rocket motors. The jettison motor is active. The abort and the attitude ones are not for this flight. We don't have people, so we're not flying a fully active abort system. We also have 3 fairings that are there to protect Orion, the service module and the crew module, as we're flying up through the really dense parts of the Earth's atmosphere. Next up, we'll hit core stage separation. So we've got 4 main engines. We'll hear MECO, main engine cutoff. Those engines will shut down, the core stage will separate, drop away. It's eventually going to splash down in the ocean. And that hands over the propulsion duties to this, our upper stage, the Interim Cryogenic Propulsion Stage, or ICPS. Its first job is to execute what's known as a perigee raise maneuver. So the perigee is the lowest part of your orbit. You have a perigee, that's your low part, and an apogee, that's your highest point. We're going to raise up the perigee, and that's going to actually put us in a nice circular path around the planet. And while we're there, that gives us time to check out Orion. We're flying it in space for the second time, the first time in this fully integrated stack with SLS. We'll be able to look at all of Orion's systems, make sure those solar arrays are capturing the sun's energy and turning it into electrical power for Orion's systems, make sure the communications are working, all of our guidance, navigation, and control. That is your time to make sure you have a healthy spacecraft before you do something that is going to send it to the moon. And that's next up on our list. That's the translunar injection. For today's launch profile, that's going to be a firing of about 18 minutes of that single engine on the upper stage. Now that engine optimized for a vacuum, it's producing about 24,000 pounds of thrust. So it's a pretty big engine, and it's doing that because we need enough energy to be able to send our payload, Orion, beyond low Earth orbit and send it on a path to head out to the moon. Now after that burn is complete, ICPS separates. It's going to do what's called a disposal burn. So it's going to send itself on a path from Earth around the moon and slingshot out into what's known as a heliocentric orbit. So it's going to completely leave the Earth-Moon system and go into orbit around our sun. But after it separates, propulsion duties get handed over to the European Service Module, and it's got a couple of different engines that it's going to be using, and we're going to be testing those out just on day one. We're going to do what's called the Outbound Trajectory Correction Burn 1, and we'll do a couple of these trajectory corrections as we're flying out to the moon, but that first one is that first critical test of this large engine, the Orbital Maneuvering System engine. That's the one that has the most thrust, generating about 6,000 pounds of force in a vacuum, and that's what's going to be doing a lot of our maneuvers, or giving us that pushing power as we do these maneuvers around the moon to enter into what's known as distant retrograde orbit, or DRO, and that's this dotted line that you see around here. Now we call it distant basically because of the distance we're away from the moon. We're about 40,000 miles, a little bit less, off the lunar surface, and then we call it retrograde because the moon orbiting planet Earth in this direction, going in a counterclockwise fashion, we're going to be entering into a clockwise orbit around the moon, opposite retrograde. Now to do that, we're going to get in close, we're going to dip in off the lunar surface, we're going to be about 80 miles, 80 statute miles off the lunar surface as we do this outbound powered flyby. Again, the major thrust coming from that Orbital Maneuvering System engine. After we do that, we'll do a final maneuver to actually go into that distant retrograde orbit, that DRO. Now, why DRO? Why are we not just going around the moon and coming back on like a free return trajectory, which we did on some of the Apollo missions? Well, in DRO, it's a very stable orbit. It doesn't require a lot of fuel to maintain that area around the moon, so it gives you a lot of time to really test the spacecraft. If you followed with any launch of a new spacecraft, you know there's only so much testing you can do on the ground. Once you actually put all of that hardware in space, in the environment that it's going to be operating, hundreds of thousands of miles away from Earth, you're going to learn things you didn't even realize about everything from communications, the life support systems, the thermal control. Everything on a spacecraft needs to get put through its paces in this environment before we put people on board, and that's why we're heading out to DRO. Eventually, though, it's going to be time to come home, and we will do a DRO departure maneuver. This, again, firing up that Orbital Maneuvering System engine and others on the service module, and this is what's going to commit us from leaving the moon and heading on back towards Earth. We'll dip in once more, close off the lunar surface, slingshot and use the lunar gravity to do this return-powered flyby, and then similar to the way out, we can make correction burns as we kind of fine-tune our path back towards the Earth. And then it's time for re-entry. A couple of things happen before that. One of the really critical ones, spacecraft separation. We're going to detach the European Service Module shortly before re-entry. Its job largely done. That burns up in the Earth's atmosphere and reveals on the crew module the heat shield. I circled it earlier. This is goal number 1 of the Artemis mission. Artemis 1 mission is testing this heat shield at lunar return velocities, because when we make that trip around the moon and we come back, we are going in speeds of excess of 20,000 miles an hour. So when we slam into the Earth's atmosphere, it's going to heat that thing up to more than 5,000 degrees Fahrenheit. For the Artemis 1 profile, we're going to do what's known as a skip re-entry. So basically, you can come in too shallow and skip off the atmosphere, too narrow, and you're going to do what's known as a ballistic entry, which really heats things up. We're going to do kind of a mix where we're going to skip once off the atmosphere, and that we're still going to get the heat, but that helps to reduce some of the G loads on the crew. Once you're through that, you get to parachute deploy. There's 11 parachutes in total that are going to slow Orion down before it splashes down. We're going to be going from 20,000 miles an hour to about 300 miles an hour before those parachutes deploy, and then they do a final job of getting it in the water in the South Pacific. We've got these big orange balloons. That's an uprighting system, so even if Orion landed in the water upside down, those can inflate, and they put us back upright into what's known as stable 1. That's where you want your spacecraft to be, nice and upright in the water, especially if you're an astronaut in there floating. Now, we also have a large U.S. Navy ship with a big bay that's going to basically come up and swallow Orion into its deck and you've got a couple of other assets in the area to help recover hardware, the forward bay cover, parachutes, things like that. But that's scheduled to happen 26 days after a launch today. So that's 26 days from liftoff here in Florida, around the moon, to a splashdown in the Pacific, and that will be the first mission in the Artemis program, the farthest we've ever sent a human-rated spacecraft in history, and just the first step before we put people on board. So that's a look at everything still to come. We're counting down to that launch. I'll send it back over to Megan and the team at the host desk, guys.
A very comprehensive look at that. Thank you so much, Dan. If you're just joining us, welcome to Kennedy Space Center and our live coverage of Artemis 1, an uncrewed flight test that will return us to the moon in nearly 50 years. But you know, some might ask, why the moon? Well, here's why.
We are going. The history of this agency is marked with broken barriers, once viewed as impossible. With science fiction turned reality, with innovations that have spun industries all their own, and with demonstrations of peace for all humankind.
We soar in the skies of our home planet. We maintain a human presence just outside of gravity, and we touch points all across the solar system and beyond. We're going back to the moon, and this is why.
The moon is a treasure trove of science.
It holds opportunities for us to make discoveries about our home planet, about our sun,
and about our solar system.
The wealth of knowledge to be gleaned from the moon will inspire a new generation of thought and action.
Without fail, every major program and mission NASA has invested in has led to technologies and capabilities that have shaped our culture.
The breakthroughs of the Artemis era will define our generation and the generations to follow.
The tens of thousands of jobs associated with propelling us to the moon today are just the beginning of a lunar economy that will see hundreds of thousands of new jobs develop around the world.
This is not an ambition of one entity or one country. The exploration of the moon is a shared effort,
woven together by a desire for the greater good.
Why the moon? Because the missions of tomorrow will be sparked by the accomplishments of the Artemis generation today.
Because the ambition to go has already begun.
And because Mars is calling. We need to learn what it takes to establish a community on another cosmic shore. So let's camp close before pushing out.
And so, we go to the moon now, not as a series of isolated missions, but to build a community on and around the moon capable of proving how to live on other worlds.
We'll use the lessons from more than 50 years of peaceful exploration to send a new generation to the lunar surface to stay.
We will anchor our efforts on the lunar South Pole to establish the Artemis Base Camp,
positioning us for long-term science and exploration of the lunar surface.
We will prove what it takes to assemble a complex ship in deep space.
We will perfect descending down to and returning from a distant surface.
We will learn how humans can survive and thrive in a partial gravity environment.
With improved spacesuit designs, mobile habitats, and with reconnaissance robots pre-positioning and relocating supplies.
We will learn how to utilize the resources we find on these other worlds, starting with finding water ice and purifying it to drinkable water.
And refining that into hydrogen for fuel and oxygen to breathe.
We will establish fission power plants on the surface of the moon, capable of supporting a growing community of efforts.
And we will expand the logistics supply chain to enable commercial and international partners
to resupply and refuel deep space outposts.
None of this is simple or easy, but nothing in our history ever has been.
The Eagle has landed. You got a bunch of guys about to turn blue. We're breathing again. Thanks a lot.
This kind of continuous lunar presence is a natural extension of all that we've learned in low Earth orbit. And what we will accomplish there will ensure the monumental missions to Mars are within reach. As we ready the launch of the first Artemis mission, and as commercial companies ready their lunar landers for the first private payload deliveries, we have already begun to take the next step.
Throughout this launch broadcast, our NASA's Leah Martin has been introducing us to people over at the...
Yeah, we're still in the hold. There hasn't been an update yet on the progress on that. You can see that the tanking is still happening, so they're still probably looking to get this thing up before the end of the launch window, which is going to be 2 hours long, roughly. So don't lose your mind before then. We have to be patient. The rocket has a temperament of its own.
And their love of spaceflight. And I actually struck up an amazing conversation with Scott here, and you were telling me about the special tie that you have to tonight's launch as well.
Oh yeah, I literally grew up with NASA. My father went to work with the NACA before NASA, went to work for Dr. von Braun, followed him over to Marshall Space Flight Center, and became, when it became NASA. He worked on the Jupiter C, Redstone, Saturn I, Saturn V, and then because of that, he brought me here to see Apollo 11 launch. So that was my first launch. I was 5 years old. I loved it. Still remember the sound. That's about all. And then years later, through my flying career, I was able to bring my sons back with my friends that flew the shuttle, and they saw 5 launches and 4 landings. But basically, I wanted to be here. I was here for the first moon launch, the last moon launch back when Uncle Gene Cernan, our family friend, went to Apollo 17. So I wanted to be here for this because it's kind of in our family, in our blood, and hopefully I'll be around for the next one when we go and land again. So that's
incredible. So you have NASA actually in your DNA, grew up with the program.
Yeah. I knew most of the German scientists, the kids sat in our lab, Dr. Ernst Stirlinger, and my father flew with von Braun because he was a general aviation pilot as well. So they'd get off work and fly, and they were in Life magazine together, National Geographic. So it was fun. I literally got to knew Al Shepard, all the Mercury, Gemini, Apollo guys, and it was an honor. I would have loved to have been an astronaut, but I went a different route, and but I can still come here and see them.
We can, and we're so grateful, so thrilled to see you here tonight, and so excited that you will be able to actually compare the last launch and the sound of the last one with the one tonight. It's absolutely going to rock the sky.
I want it to be even louder. I want to feel it. Yeah.
Thanks so much for joining us tonight. It's been an honor to meet you.
I don't know if the sound is going to be exactly the same as the Apollo. It's definitely going to be a cleaner sound because well, let me think about that. The Apollo was running on basically RP1 and liquid oxygen, so this one has solid boosters. So that's definitely, like, the solid booster sound is definitely a lot more, let's just say, energetic. So it'll definitely be louder, but it'll be similar to how the space shuttle sounds, to be honest. So if you've seen a space shuttle launch, it'll be very similar to that. The only difference in terms of the engines between this and space shuttle is that you have a 4th engine. So maybe it's a little bit louder, but like you probably won't notice. You could probably superimpose the audio of both of them onto each other, and you wouldn't notice too much of a difference. I would expect. But we'll see, I guess. If it launches, we'll be able to make that comparison ourselves.
People there decided to hold a watch party, and
look,
that's
our
exciting
friends in
to see.
Germany are ready for us this time.
That's where we are, in Germany.
We anticipated the delay. They look pumped and ready to go.
Looks like there's a bit more people there now, because now it's
employees of Airbus.
7:30.
Airbus is a main contractor for the European Space Agency, and together they provided the European service module for the Orion spacecraft. So really, we should be applauding them. They shouldn't be applauding. Thank you so much, guys, for your contribution to the program.
They're applauding because they're finally maybe going to get to see their work fly.
SLS Launch. Okay, so now let's head back over to Daryl Nail over with the launch team so we can hear any updates about a new T0.
Yeah, Megan, thank you. And a clearer picture is starting to emerge as the launch team now reports out that they only have a few minutes left of work to do before they're ready to pick up polling. And we're also hearing that some of that polling, which kicks off with the mission management team, is also now just about 3.5 minutes away. Now, we are currently still in that hold. But the launch team, NASA's test director, is continuing to move the team forward. We've wrapped up work on the upper stage and the lower stage. You're looking now live inside firing room 1, where launch director Charlie Blackwell Thompson is overseeing her launch team. We've had a number of delays that have put us off the T0, but we are starting to track to a T0 close to around a quarter till, top of the hour. But we do need to have some polling that takes place. I'm pausing now because I'm listening in to the teams as they communicate.
Do you guys see that flare tower there? I think they're
in this launch
flaring
window,
hydrogen.
which we're currently 26 minutes into, and it's 2 hours long. It runs until 3:04 a.m. Eastern Time. We have what's called 40 cutouts. And in those cutouts, they range from about a second to about a minute. These are times where they can't launch. These cutouts must be accounted for when determining a new T0.
Those cutouts are because they have to make sure they're not launching at a time when there might be a satellite passing over that they could hit.
The rocket, which was the last to get ready and configured. Just recently, the team cycled the liquid hydrogen valves, which is required. And they are currently working on the LO2 valves, liquid oxygen valves in the upper stage. That work is almost done.
So this is looking a bit more promising. We might get a new T0 relatively quickly here.
We are now a minute and a half away from the poll of the mission management team, which is several minutes before T-minus 15 minutes.
So I'm guessing they're probably going to try for like...
When that poll starts, we'll get a clearer picture of our T0.
I'm guessing it'll probably be in around 25 minutes or so. Is probably what they'll go for. But yeah, those cutouts that they have are just because they don't want to launch when they might hit something that's on orbit.
NASA's test director has informed the launch team to all switch to a common communication channel. It's called 232. And what this means is that the entire launch team is now on one channel, and all future communication will happen there, whereas there are many channels. Now they reduce it down to one. Just heard from NASA test director Carlos Monge. I'm sorry, Jeff Spaulding. Jeff Spaulding's on. They swapped out. There are currently no constraints to launch.
Aha!
Great
there we
news.
go.
Again, no constraints to launch. And they're getting ready to pick up with a poll to determine readiness for launch.
So it looks like we're fully fueled now. And good that there are no constraints. I think this might be the one, guys. This might be the one. But But yeah, we're about 20 minutes away from in the countdown, as he was saying, from what would be the T0. They don't have one specifically picked out yet, but once they get through that poll they do at 15 minutes, I think they will probably select their T0. And they kind of have flexibility with T0. It's not like the instantaneous launch windows that you have sometimes with like SpaceX and the Falcon 9. They have kind of a long window of 2 hours, and that's just because they're going into basically an equatorial orbit.
NASA Test Director Jeff Spaulding getting ready to conduct the readiness poll, so we are getting close.
Okay, just looking for that readiness poll. I've noticed there's a flare tower.
Pull up the audio now.
Okay, we're gonna get
so that you can listen in.
LPs go. And rock. Rockets go. All right, copy all. And Launch Director NTD, our launch team is ready to proceed at this time.
I copy all NTD. At this time, I will proceed with my poll. And attention on 232, this is the Launch Director performing the final poll for launch. Verify no constraints and go for launch. EGS Program Chief Engineer.
EGS Program Chief Engineer verifies that the EGS, SLS, and Orion Program Chief Engineers have no constraints and are go for launch.
Copy, Greg. Thank you. EGS Chief Safety Officer.
The EGS CSO verifies the SLS Orion and EGS CSOs have no constraints and are go for launch.
Copy, John. Thank you. Range weather.
Weather has no constraints and weather is go for launch.
Copy, LWO. And Mission Manager. And Mission Manager, Launch Director.
Launch Director, Mission Manager on 232. The mission management team has been polled. You have a go to proceed with terminal count and launch of Artemis 1.
I copy all. Thank you. And NTD, Launch Director.
Go ahead, Launch Director.
Yes, sir. On behalf of all the men and women across our great nation who have worked to bring this hardware together to make this day possible, and for the Artemis generation, this is for you. At this time, I give you a go to resume count and launch Artemis 1.
Copy, Launch Director, and thank you. All right, we do have a couple of steps to configure, and then we will be ready to resume the clock. CVSE, NTD.
CVSE here.
Initiate recording of Orion cameras at this time.
In work.
R, NTD.
RSR here.
Perform the booster ignition SNA arm rotation enable.
NDT, RSR, booster ignition SNA arm and rotation enable is complete.
And I copy. Thank you.
Okay, so there you heard the poll from Launch Director.
Early.
It looks like we're good to go.
Getting ready to get that new T0 time.
Which means we're probably around 15 minutes away from the launch at this point.
The poll that you heard was the NASA Test Director's poll. And
all right, and we have verified no cutouts at this time. And all personnel, we are going to resume the clock. GLS, you can resume the clock on your mark.
GLS copies. Countdown clock will resume on my mark. 3, 2, 1, mark. GLS mainline has been initiated.
Okay.
T-minus 10 minutes and counting.
We are T-minus 10 minutes away from liftoff of Artemis 1. As you can see, the clock is now moving. Let's put that up.
All right.
T-minus 9 minutes and 47 seconds. The L-minus 15 poll complete.
Show 06:47, 44 is the new liftoff time.
Affirm.
Okay.
Just 9 more minutes. Man, I'm actually getting pretty excited here.
01:47:44, 1:47 a.m. Eastern Time and 44 seconds.
This is the closest we've gotten so far.
We went straight into terminal count. Liftoff now 9 minutes away. So terminal count. Control has been given over to the GLS, the ground launch sequencer, a computer and software that is doing all of the commanding and monitoring of the Space Launch System. We'll hear call-outs from the GLS operator, Alex Pandalos. As well as NASA Test Director Jeff Spaulding. GLS is pre-tensioning the umbilicals at this very moment. You can see them as they run down the rocket. That's getting them ready to detach.
Those umbilicals are what are supplying
lift off, those arms will swing
the
away,
fuel and the oxidizer
let go of
to
the
tank.
rocket in a clockwise direction.
And basically those are going to rip off as the rocket is launching, basically. So it's kind of like the Apollo days when you have the tower like rotate as the
T-minus
rotate
8 minutes
off
and counting.
as the rocket launches.
The GLS is performing up to 100 commands per second, including configuring ground systems for power transfer to the rocket.
And basically, those umbilicals can come off.
GLS is turning on
because
cameras,
they're all
recording video inside and outside the crew module to collect data for engineers.
The cameras are what we care about, of course.
Purging the aft skirt booster with high flow nitrogen.
Give us some good
Clear out
footage.
any hydrogen gas that may be there.
I hope they have a camera that
You
they're
can see the
streaming
crew
from the
access arm is
vehicle.
already retracted. When there is crew during Artemis 2, it would happen at T-minus 6 minutes. But out of abundance of caution, they went ahead and retracted the arm well ahead of liftoff. Want to point your attention to the base of the mobile launcher. If something wasn't done to reduce the power from the pressure caused by the rocket's ignition and thunderous sound, it could damage the rocket. So the ignition overpressure and sound suppression system will flood the mobile launcher with water. You'll see that sequence start at T-minus 17 seconds.
Basically, it just sprays water at the rocket, and
Now coming up in
dampens
less
the
than 30
sound
seconds,
and the
the
vibrations.
ground launch sequencer will start bringing the high energy systems online, starting with core stage pressurization.
All right,
Fire room 1
coming
is
closer.
completely silent as they listen for the next call.
GLS is go for core stage tank pressurization.
They have
The
to
core
pressurize
stage
the
tank
tanks.
is now pressurizing to flight levels.
They have to pressurize because the
The
pumps
replenish valve
need
to the liquid
pressure.
hydrogen tank now closing.
The pumps need pressure in order to actually run.
The
Otherwise, they
liquid
can get
oxygen
damaged.
tank will come a little later. Now we're arming the Orion ascent pyros and transfer to internal power. The launch abort system, or LAS jettison motor, is now armed. On this flight, the abort motor is inactive because there is no crew on board. Up next is the flight termination system, or FTS, which gives the Space Force the ability to destruct the rocket if it goes in the wrong direction. Let's listen in for that.
The crew will not have a flight termination system, of course, because you don't want to terminate the
GLS
rocket
is
with
go
people
for
on board.
FTS arm.
The flight termination system is now armed. Coming up at 4 minutes and 40 seconds, a big moment. This is where the RS-25 engines and their bleed go to high flow. It's been
Those
a
are
little
the
tricky
upper
to dial
stage
in.
engines? The ones that are using the expander cycle?
GLS is go for LH2 high flow bleed check.
Good word, we've passed that. The cryo team got the LH2 engine bleed pressure loop dialed in. They are now at the right temperature for launch. Countdown continues. T-minus 4 minutes, 15 seconds.
They have to
Up
get a
next,
bit cold,
GLS fires up the
those engines.
K-POOs. Those are high-speed turbines which provide pressure to hydraulic pumps that steer the RS-25s. stands for Core Stage Auxiliary Power Unit start.
GLS is go for core stage APU start.
That now leads to the thrust vector control test at T-minus 2 minutes and 30 seconds. That can proceed now, and we will see the engines gimbal at the bottom of the core stage.
If you remember, they would also do this test on SLS. It's actually kind of one of the coolest parts, I think. It's like when the pilot moves the flaps before the flight, you know? Just to make sure you
At T-minus 3
control.
minutes and 10 seconds, you will hear the go for purge sequence 4. That's a helium purge of the 4 core stage engines downstream of the propellant valve, getting the air and moisture out.
GLS is go for purge sequence 4.
And in just a few seconds, GLS will close the core stage LOX vent, liquid oxygen. The white vapor cloud caused from the super cold gaseous oxygen condensing the water in the atmosphere will disappear. You see it coming out there now. And there it goes, it's closed. LOX vent closed, pressure rising in the core stage LOX tank to flight levels.
So no more letting
Coming
out
up
hydrogen.
in 15 seconds, look for that thrust vector control actuator test. Engines will gimbal.
You should see the engines kind of moving back and forth.
And there they go.
Kind of doing a dance there.
The 4 core stage RS-25 engines gimbaling around, testing the ability to steer the rocket
Look at
into
that
space.
range. It's crazy how much these things can gimbal. This is one of the coolest things about the RS-25s is how much they can move around
performance.
like that.
Each RS-25 throwing down 500,000 pounds of thrust. All 4, 2 million pounds. All together with the boosters, 8.8 million pounds of thrust.
GLS is go for upper stage to internal power.
Now the upper stage has gone to internal power. So power is removed from the rocket's upper stage, the ICPS, and it's been switched to battery power. The same milestone is coming up for the core stage at T-minus 1 minute and 30 seconds.
GLS is go for core stage to internal power.
So
The
everything's on
rocket's core
internal
stage,
power
which
now.
houses the 3 flight computers, is now on battery power. So there is no more hold time available because there's no more margin on the batteries. So if we have a hold, we'd have to recycle back to T-minus 10 minutes and recharge those batteries. The count continues. A note now, shortly after liftoff.
1 minute.
Shortly after liftoff, Mission Control Houston will take control of the rocket, and my colleague, Leah Cheshire, will take over commentary. T-minus 50 seconds and counting. Coming up at T-minus 33 seconds, the GLS will hand off control to the ALS. This is the autonomous launch sequencer.
Do you see that
on board the rocket? It will
white,
take
black
over
square?
command and control of
That's
the rocket.
for tracking.
But the ALS will check, make sure there's no holds coming from the ground up until T-minus 2
GLS
seconds.
is go for ALS.
And we are go for ALS. The Space Launch System is now counting down to liftoff of Orion on its maiden voyage to the moon.
All right, it's going to launch, guys.
Launch team can
20.
no longer recycle the count. Sound suppressor water now flowing
15.
under the ML.
It's going to go.
And here we go.
Here we go.
Hydrogen burn-off igniters initiated. 7, 6, 5. 4-stage engine start.
Wow.
3, 2, 1. Boosters in ignition.
There she goes.
And liftoff of Artemis 1. We rise together back to the moon and beyond.
Would you look at that? The biggest rocket in the world right now.
All 4 RS-25 engines on the core stage and 2 solid rocket boosters now propelling the vehicle at 128 miles per hour. Hearing good control on the roll from teams in Mission Control Houston. All good calls so far. Now 30 seconds into the flight of Artemis 1. First milestone will be for the vehicle to pass through max Q at about 1 minute and 9 seconds into launch. This is the greatest period of atmospheric force on the rocket. SLS now traveling 607 miles per hour.
It'd be nice if they had the telemetry data on the screen. But
you're looking at 8.8 million pounds of maximum thrust. Quiet here in the loops in mission control. The 4 core stage engines are throttling down ahead of passing through max Q.
This is just an incredible flame that this thing produces. Nothing quite like it.
Now 1 minute, 21 seconds into the flight, traveling at 1,420 miles per hour. The 4 core stage engines are back at maximum thrust. The next major milestone will be for the solid rocket boosters to cut off and jettison at about 2 minutes and 11 seconds into the flight, so about 30 seconds from now. Again, quiet here in Mission Control Houston as teams continue monitoring the flight of Artemis 1. We're now 16 miles downrange from the launch pad at Kennedy Space Center, traveling over 2,800 miles per hour. Standing by for solid rocket booster jettison and shortly thereafter.
Okay, they'll be jettisoning very quickly here. Yeah, there they go. You just saw them. There they go. So now it's just, you can see the two
confirmation that the
rockets have
solid
just
rocket
separated,
boosters have separated.
and you can see
These
the 4 main
177-foot boosters.
rockets still going. You can see how
Now the core stage
much less
continues
bright
to
they
power
are.
the flight of Orion, all 4 RS-25 engines firing, traveling over 3,400 miles per hour, 46 miles downrange.
And the reason why you can still see those solid boosters is because they're still
2
burning
minutes and
the
36
little
seconds
leftover
into the
propellant
flight.
in the stage. And
Hearing
they're still
nominal
glowing
calls here in
hot
Mission
from
Control
the
Houston.
ignition.
We've still got 4 good engines on the core stage. Next up, we'll be looking for the service module fairing to separate. This is 3 15 by 15 foot fairing panels, providing structural support, protecting the service module. Those will separate at about 3 minutes and 11 seconds into flight, and very shortly thereafter will be followed by the launch abort system separation.
It's looking like it's a bit tough to track
Just over
this
3
thing.
minutes into the flight of Artemis 1, now traveling over 4,060 miles per hour, 83 miles downrange. We just had confirmation that the service module fairing has separated.
Oh, we do have an onboard camera. Briefly.
And that the launch abort system pyros have fired, separating those from Orion as well. For future crew members.
So the launch abort system is gone now. That was weird. They just cut out.
We just heard the call for 3 engine press, meaning if SLS were to lose an engine at this point in the mission, we could still achieve a nominal mission. We would just have an extended main engine cutoff time. However, we still have 4 good engines, all at maximum thrust right now, powering the first flight of Artemis at 5,200 miles per hour, 148 miles downrange.
So this is going to go for probably another 5 or 6 minutes. I can't tell where we are in the launch, though. Oh, here we go. Finally, they put the clock on. They just like removed the clock at the start of the launch.
We're 4 minutes and 16 seconds into the flight of Artemis 1. So far, we've had a clean ascent. We saw those solid rocket boosters jettison about 2 minutes and 11 seconds after liftoff. Shortly after, we had the service module panels fairings separate, as well as the launch abort system. The launch abort system was inert for this flight, except to perform this separation. Those 4 core stage engines will continue to fire and power the flight of Artemis 1, now traveling over 6,800 miles per hour, 229 miles downrange. Booster flight controller reports that the engines are looking good. Our core stage main engine cutoff time is about 8 minutes and 3 seconds. We are now 5 minutes and 11 seconds into the flight, 7,656 miles per hour.
So we're just coming up. We're just past halfway now.
Again, 4 good core stage engines, those 4 RS-25 engines.
Just a reminder that we need to get up to
the last time those core stage
28,000
engines
kilometers
flew,
an
they
hour.
were taking space shuttles to orbit, and now with upgraded capabilities, they're launching the future of human spaceflight.
But unfortunately not getting reused. It's really sad. All that engineering for reusability, and now
5
this
minutes,
will be the last
42
flight.
seconds into the mission. We are now traveling 8,800 miles per hour, 345 miles downrange from the launch pad at Kennedy Space Center.
So yeah, it's really too bad that they that they don't.
Again, we are
guys.
anticipating core stage main engine cutoff at about 8 minutes and 3 seconds. And about 10 seconds later, we'll see core stage separation, at which point Orion and the interim cryogenic propulsion stage will be flying free. Now traveling over 10,000 miles per hour, 6 minutes and 15 seconds into the flight of Artemis 1, 427 miles downrange. Quiet here on the loops in Mission Control Houston. Teams continue to monitor this first flight.
All right. It's unfortunate we don't have cameras on the main stage.
About a minute and a half now until that core stage main engine cutoff time. Our 4 core stage engines continue to fire maximum thrust.
Everything's looking nominal so far. I would like to show them to show more telemetry data. We kind of just have the timeline on the bottom, but we'll have to satisfy ourselves with that.
Coming up on 7 minutes since launch today, now traveling over 12,800 miles per hour, 563 miles downrange. Again, still quiet here in Mission Control Houston. As we prepare for main engine cutoff, the 4 RS-25 engines are beginning to throttle down.
There was a question earlier about when our rocket is slated to launch. We are targeting 2023 for our small rocket launch, which
30 seconds now until core stage main engine cutoff. All 4 engines continue to throttle down.
For the big one that goes to the Kármán line, we're probably going to launch that in the spring of 2024. Just if you're curious and still watching.
Now 7 minutes 45 seconds into the flight, traveling over 16,000 miles per hour. Continuing to hear good calls here in Mission Control Houston. We're standing by for core stage main engine cutoff.
All right, so once this happens, the main stage is going to separate, and that second stage is going to be pushed off.
And we have confirmation of core stage main engine cutoff. Orion is now in Earth's orbit. The Flight Dynamics officer reports that we have a nominal main engine cutoff. And we just heard the call for core stage separation. That means Orion and the interim cryogenic propulsion stage are now flying free from the core stage of the Space Launch System. The next milestone will be solar array deploy approximately 18 minutes after liftoff. But before Orion stretches its wings, let's check back in with our friends at Kennedy Space Center and hear all about what it was like to hear the rocket roar off the launch pad. Megan and Kayla, I've got to hear all about it.
Well, if you're just joining us, welcome to NASA's Kennedy Space Center, where we just watched Artemis 1 launch, our first step towards our next adventure into deep space. As Leah said, I'm NASA's Megan Cruz, and this is NASA astronaut Kayla Barron. And I'm kind of still giddy and speechless. I don't even know how to explain how I'm feeling right now.
I feel the same way. This is the first launch that I've been able to watch in person, and I've got to say, it was incredible. It took my breath away, and I was tearing up. Just what an amazing accomplishment for this team, this international team, people who have been dedicating their careers to getting this rocket off the ground.
Yeah, like you're saying, it's not
the
really
first step to getting a crew on that vehicle back to the moon. It was just incredible.
Yeah, this is a moment I think that we're all going to remember where we were when we saw this sort of thing. You know what I mean? And it was great to see.
I think they're a little bit,
again, when we entered into terminal count, everybody here just started cheering. Coming out together.
They're usually a little bit hesitant to show all the cool stuff on the test flights. So, and NASA is kind of a public organization, so they have a particular face that they want to show the world. I don't know. Putting a camera onto the stage of the rocket was never something that they did in the past. So, I guess they have to get used to that modern thing that these private launchers do to show off their rocket. Because of course, private companies are trying to sell their rocket as well. And what better way to sell your rocket than to actually, show it in operation? But NASA is not really needing to sell their rocket. Like the rocket's already there for their mission, right? So they have less of the impetus and reason to be doing this in the end, I guess.
In that moment of liftoff, when
but yeah, maybe in the future they'll have some better equipment for live streaming and showing this to the world, because I think this is really cool. They should show more of the biggest launch vehicle ever to launch the biggest launch vehicle in operation today, and eventually what will be the biggest launch vehicle ever when they get to the final configurations. It's a great thing to show off for their program, and to show off the billions of dollars that they spent on this. I mean, how much does it cost for a camera? My goodness. Just put a camera on the stage so you can see what's going on. But maybe they'll have some camera views in their Orion capsule later on in the mission, and they might release some videos afterwards of the engineering cameras, but we'll see. They do have cameras on board for engineering reasons. They definitely turn those on.
How much it lights up the night sky. We were able to watch it all the way through that trajectory. We were able to see the boosters separate and everything. So it was just an incredible view. It's amazing how.
Yeah, I'm a bit surprised they didn't broadcast more as well, just because of the hype that this launch had and the expectations that were around it. So I kind of agree with your thoughts there. Yeah, like you said, the space shuttles definitely had more cameras involved than this one did.
We're going to head over to Daryl, who was at the launch team. Daryl, you got to count us down through that, through liftoff. I mean, how was that being in the launch
So yeah, we're just standing by here for the next 5 minutes or so. They're going to deploy the solar panels, and then I don't know if they're actually going to light up that engine for a while. They can kind of hold in this orbit for a while because they're already in orbit. So it depends on when the decision for doing that is. But yeah, definitely stay tuned on the NASA channel for looking for replays and stuff, because they do have cameras on the booster, because you heard the call out that they were turning those on. So
the room can't.
I think we can't hear the flight director right now. What's going on? Not sure what's going on with the flight director right now. This is odd.
I don't know what he's telling me to do.
But yeah, definitely check in with NASA, the NASA channel, because they probably will put more videos of the launch now that they know it was successful, so they'll release some of the data, I'm sure. But they definitely have to get a better live stream like template, like with maybe the speed of the rockets and like the altitude and maybe like a trajectory, a display that shows where the rocket is on the launch, like things that like a lot of the private space companies have. I think SpaceX's looks really nice. Maybe they could,
He's here?
Get some pointers. I don't know.
Can you guys hear me? Oh, there we go.
And they're back. They've established communication with the launch control room. Not sure what happened there.
Well, for once, I might be speechless. So you guys know I have talked a lot about appreciating the moment that you're in. And we have worked hard as a team. You guys have worked hard as a team for this moment. This is your moment. It is not by chance that you are here today. So I want you to look around at this team and know that you have earned it. You have earned your place in the room. You have earned this moment. You have earned your place in history. You were part of a first. Doesn't come along very often. Once in a career, maybe. But we are all part of something incredibly special, the first launch of Artemis. The first step in returning our country to the moon and on to Mars. What you have done today will inspire generations to come. So thank you. Thank you for your resilience. You know, I said at the pre-test briefing, the harder the climb, the better the view. We showed the Space Coast tonight. What a beautiful view it is. So congratulations.
Did they really show the Space Coast, though? I feel like they could have had some more cameras to show some more.
So we got a couple of traditions here in launch control. And the first one is when you're in the position for the first time, you get a tie cutting. And so I have my launch director scissors. And I'm going to get my tie cut by a couple of legends that are here. And then anyone who wants their tie cut will be making the rounds in the firing room. You got your console chiefs. If they want to do it, that's fine. If you want me to do it, you might have to wait a little while, but I'll stay all night if I have to. It'll be my pleasure to cut ties. So I'm going to take care of mine, and then I have one other presentation that I want to make this evening.
Man, did we lose their audio again? They're really struggling with the communications in that room today. But yeah, good to see that they're keeping up the traditions of NASA. They have all these traditions back from the Apollo period and from the space shuttle period. So it's good to. I like the culture that they keep doing these things because it kind of keeps the rocket culture alive, so to speak.
This is Charlie Blackwell Thompson, Artemis 1 launch director. She just got her tie cut. That is a tradition here at NASA. We just got to hear her talk to the team, and one thing that really stuck out to me that she said is that they've really earned their place in history. We're coming up on solar array deploy. Let's go on to Leah.
Let's see if they're going to show those solar arrays deploying. Hopefully they do.
Thanks, Megan. And yes, we're here in Mission Control Houston, still monitoring the Artemis 1 mission and the first flight of Orion atop the Space Launch System. So far, we saw successful liftoff at 1:47 a.m. Eastern Time, all the way through separation from the core stage. We now have Orion and the interim cryogenic propulsion stage flying free. And we've just heard that we have initiated solar array deploy. So we are turning our focus to that. The spacecraft was running on battery power, but stretching these wings will allow it to stop relying on those batteries and significantly extend the time it can stay in space. So solar array deploy takes about 12 minutes. We have 4 solar arrays that we need to deploy and latch. These will provide power to the spacecraft on its journey to distant retrograde orbit and all the way back to Earth. Once these are properly configured, again, Orion will no longer need to rely solely on battery power. And we expect this to be done about 30 minutes after liftoff. Right now, we're 19 minutes since liftoff today. Orion is now traveling 17,175 miles per hour.
Okay,
We're continuing to hear good calls here in Mission Control Houston from the flight controllers monitoring the mission. A little bit about these solar arrays as we wait. Again, we heard the call that the deploy has been initiated. We'll hear a little bit more about that once they start to unfold. These 4 solar arrays generate 11 kilowatts of power, which is enough electricity to power 2 3-bedroom houses, and they have a wingspan of 63 feet. Just one of these 6.5 by 6.5 foot panels has 1,250 solar cells. So you're looking at a total of 15,000 solar cells.
So just imagine, that's like huge.
Now we just heard the call that all 4 solar arrays have been released. So we initially heard the initiation call. That command had been sent. Now those 4 solar arrays are released. Again, this is about a 12-minute process.
And we are getting some.
These solar arrays will deploy straight, and you're getting a live view right now. This is really exciting.
Shortly.
They'll eventually be swept back against the vehicle prior to translunar injection burn to prevent any loads from breaking or damaging the arrays. And on the end of each solar array is a camera that will capture imagery for us throughout the mission, along with a few other cameras placed outside and inside the spacecraft to help us monitor and perform various other inspections.
So they're unfolding these solar panels basically like hinges, so they are all clapped down like this, and they basically unfold like this, and they have a camera that's on the edge of the solar panel that's looking down, and that's the camera they were switching to. I'm not sure what this one is that we just saw.
To the energy available for use from the sun.
Yeah, this is now sitting
Coming up on
the top
21
of the
minutes
vehicle,
since
looking down, I
liftoff.
think.
Orion is attached to the interim cryogenic propulsion stage. You can see those 4 solar arrays unfolding now. And again, Artemis 1 is a flight test. It's paving the way for a sustainable presence at the moon. Looking forward to the future, Gateway will be our space station in lunar orbit. And we have some similarities and differences in the solar arrays unfolding right now on Orion and those that'll be on Gateway. So like we're seeing now, these are deploying autonomously. The Gateway solar arrays will as well. And while these generate those 11 kilowatts of power, the 2 rollout solar arrays, or ROSAs, on Gateway will generate 60 kilowatts of power. That ROSA design is currently being tested aboard the space station. We have 2 new ones installed and a spacewalk conducted earlier today, preparing for another set.
Those are some pretty serious high power solar panels. So yeah, 11 kilowatts for just a little tiny
Coming up on 22 minutes
spacecraft
since
like this
liftoff
is
today,
like,
Orion and the interim cryogenic propulsion stage traveling over 16,800 miles per hour.
it's definitely heavy duty for sure.
The solar arrays deploying now are part of the European Service Module. It's comprised of 20,000 parts and components. The service module was developed as part of an agreement between NASA and the European Space Agency, or ESA. This is the first time NASA is using a European-built system as a critical element to power an American spacecraft.
So it was cool to see a couple of live shots of the deployment. So at least we had that. Although it seems like they're suffering a bit from bandwidth issues. So we only ever get a couple of seconds. But better than nothing, I would say. I particularly like the view of the camera on the edge of the solar panel as it unfolded, so you could like see the unfolding happening. That was definitely a cool shot. And the one that's behind that looks at the solar panel deployment like from the back, that one's also a pretty nice camera to have. But I'm curious what it looks like inside of the capsule. They should have something fun in there. Like SpaceX usually puts something like interesting and like whimsical into the capsule for their first test. They definitely could have benefited from that and showing a camera of that or something. It's always good to have those little connections. Maybe I can show you. We actually have a potential passenger that will be going along with our rocket to the Kármán line.
Coming up now, and 24 minutes into the flight of Artemis 1, spacecraft now traveling at 16,500 miles per hour around the Earth. We are in solar array deploy, and we have confirmation all 4 arrays are deployed.
So this is good to see. But yeah, we'll be taking a little bit of a whimsical payload ourselves. This is our Octonaut, who will be traveling in our rocket, and her name is Octavia, and she'll be also joining for
Coming
a lot
up
of the
in a little
testing
less
that
than
Astra
30
has.
minutes is the perigee raise maneuver.
So look out for her in a lot of the videos that we make. She'll be riding along. So I think they're going to be getting ready for the a quick burn of the engine. I'm not sure if we're coming up on this or not closely. Would be cool to see a live view. I think they have one there on the screen. You can see it. Yeah, you can see the live views just on the top of the screen. Yeah, here we go.
And with our launch at 1:41 Eastern Time this morning, we are looking for a perigee raise maneuver about 53 minutes into today's flight. Again, we are now 25 minutes and 47 seconds into the flight, and we have a complete deployment of all 4 solar arrays. Orion's journey to the moon continues as planned. Again, looking forward to that perigee raise maneuver. That'll be coming up again at about 53 minutes into the mission, so about 27 minutes from now. During the perigee raise maneuver, the interim cryogenic propulsion stage will use its RL-10 engine to lift the lowest point of Orion in Earth's orbit. The current orbit is more of an oval shape than a perfect circle, and this burn will raise that point closest to Earth and make the orbit more circular. This will also include a checkout of Orion's systems and any adjustments to the solar arrays. It'll be a short burn, less than 30 seconds long, but critical to keep us on track, and it also prepares us for the next engine burn to send Orion to the moon. That's the translunar injection burn. That'll come up a little later, which is a longer burn, another firing of the RL-10 engine on the interim cryogenic propulsion stage.
So yeah, the rest of the mission will be unfolding a little bit later because, of course, the way they decided to get into orbit was a bit more focused on doing like checks and stuff. So they're not just going straight into the translunar injection. They're gonna raise the orbit to get in a circular orbit, check things out, and then do that final burn with the RL-10 engine. A quick question that was there, what is Octavia's mass? She's only about 20 grams, so definitely an easy payload to take to orbit. For now, though, we can be confident that the main elements of the rocket did work out properly. So barring a problem with the RL-10 engine, which has, I think, a perfect reliability record. It's one of the most fantastic engines that have been made in the US, I would say. So everything should be fine at this point. We should be seeing the Orion capsule heading out to the moon relatively soon. Unfortunately, I cannot keep streaming that long. I have to get to the Space Tech Expo that's here in Bremen right now. We're actually exhibiting at that expo, so we have a bunch of our hardware that's there. Do follow up with us on the channel because we will be posting like short videos about what's going on at the stand and stuff and what we're displaying and how the stuff works. So do check in if you're interested about what Astra's up to and what we're building and stuff. And there's also a bunch of student groups at this expo that are kind of near us, so we're going to be showing off what they're doing as well. So you can kind of see what the students' rocketry amateur community is like in Europe, which is, I think, pretty exciting because it's definitely developing quickly. So with that, I'm gonna sign off. I'm very happy to see this SLS rocket finally ascending to the heavens where it belongs. We've definitely been waiting for many years to see this rocket launch. Man, like it's like ever since the space shuttle was canceled, we've been waiting for this rocket. So it's finally good to see NASA back in their element, building rockets that are actually taking humanity to new places. I think this is going to be important. Maybe not the most modern rocket in a sense, because they derived a lot of parts from the space shuttle, but definitely cool to see them pushing the boundaries in terms of how big you can build a rocket. Yeah, looking forward to how the Artemis program unfolds and hopefully getting humanity back to the moon. So thank you for joining, and be sure to keep following up with NASA with the rest of this mission. Over the next couple of hours, they will be performing the final maneuvers to get them on that trajectory to the moon. So definitely keep following along with them. Anyways, I hope you guys continue to remember to expand your horizons.